The Maria, or lunar seas, are testaments to the moon's volcanic past. These vast, dark, ancient plains of solidified lava can easily be viewed from Earth, even with the unaided eye. But while the results of lunar volcanism are easy to see, the actual lunar volcanoes are much less evident. There is a noticeable lack on the moon of the kind of towering volcanoes we have here on Earth. Craters abound, but they were almost all formed from impacts by asteroids. Looking closely, we can find the sites of past eruptions, though. Rimas Hyginus is a fine example of a straight rill. 220 kilometers long, it formed when magma from the moon's mantle forced its way up through a crack in the lunar crust. As the intruding magma widened the crack, parallel faults were formed on the surface above. Chambers of pressurized foam formed at the top of the rising magma below. The faults above provided a path for that pressure to be relieved through what must have been spectacular pyroclastic volcanic eruptions. As the pressurized chambers were evacuated by the eruptions, they collapsed, resulting in volcanic pit craters on the surface. The crater Alphonsus, 110 kilometers across, has a floor that is crossed by a number of straight rills. At places along these fractures, we see rimless volcanic craters surrounded by dark halos, deposits of volcanic ash. These are the sites of volcanic fire fountain eruptions. Rima Hadley is an example of a sinuous rill. This looks more like a riverbed, but no water ever flowed here. It was formed by flowing lava erupted from pits at the channel's heads. Rima Hadley is roughly 130 kilometers long and was explored in 1971 by the crew of Apollo 15. Valles Schroederi is the largest of the moon's sinuous rills, measuring 160 kilometers long, as much as 10 kilometers wide, and up to 1 kilometer deep. None of these look much like the volcanic peaks we have here on Earth. Volcanic peaks do exist on the moon, but they tend to be small volcanic shield volcanoes with such gentle slopes, typically only 1 to 3 degrees, that can be difficult to see visually. In this view, with LRO's wide-angle camera, the shield volcanoes of the Hortensius domes are very difficult to see, but instruments like the laser altimeter can reveal the subtle slopes of the domes. The low profile of these peaks is due to the low silica content of lunar lava, making it very thin and runny. Here we see the Marius Hills, again very hard to see visually, but laser altimetry allows us to see that these peaks are somewhat steeper and the lava must have been somewhat thicker. In just a few places on the moon, high silica magma erupted, resulting in pasty lava able to build tall, steep volcanoes, like the Gruithuisen domes, standing 1.7 kilometers tall. Why was the lava here so much different? That is just one of the many mysteries of the moon.